Hello, everyone. How are you doing today? Good. My name's Aiden. Going to be giving this talk today. I just want to start with, if you want to raise your hands, is anyone here in the broadcast industry, TV, all that kind of stuff? Okay, most of the room. That's good. So, let me grab that one. My name's Aiden. I run a little YouTube channel about virtual production and Unreal Engine. I've worked on plenty of TVCs, feature films. I've been working at a company called Girraphic, and I am the virtual production tech lead there. Don't worry, all the QR codes in this slide will also be on the end, so if you need to scan them, that's fine. So who is Girraphic? Girraphic is, or Girraphics, it's a portmanteau of giraffe and graphic, and we are, I guess, the leaders in broadcast AR. At least we say we are. And we have last year done some of the most watched live events ever, such as this one. It's a bit of a snooze fest if you actually watched it, but it pulled in over 100 million viewers. That's, Super Bowl level viewers for Netflix. Also did Thursday Night Football on Amazon Prime. They're breaking regular season records with just regular season games, I guess. Also some of our AR graphics. And Netflix's Christmas, again, also breaking Christmas records for Netflix, and unlike the Paul Tyson fight, marking a substantial increase in the reliability of their live streams. So, what has this all got to do with Unreal Fest? Well, all of these things you just saw are using Unreal, and only Unreal, except for Thursday Night Football. I'll put an asterisk on that. So no fancy plugins, no, alternate engine versions or anything like that, just plain old vanilla Unreal. So the question, I guess, on everyone's mind is, why Unreal? So, Unreal is this new kid on the block, right? So are these streamers, Netflix, Amazon Prime, they're looking to differentiate themselves from the traditional cable networks and what have you. So that's where Unreal kind of fits in nicely. So I've distilled it to these handful of things here. That Unreal versus traditional render engine. So if you're in the industry, you may know these. I'm not going to name them. But there are some long-term players in the industry. And so what Unreal has over those long-term players is things like the Niagara particle systems, Chaos cloth and physics, the VDB, skeletal, alembic, blueprints. That's both the actual blueprints as well as the concept of game programming in it, as well as talent. So, and that's a big thing. Obviously, there is a lot of easy ways to get knowledge about Unreal on the internet. Epic has their dev portal. There's also tons of YouTube videos, other articles, which is a fantastic way to get knowledge. Unlike some of the more traditional render engines used in broadcast graphics, generally to get knowledge on that, you have to have an internship at a TV station that already uses one, and then learn off a more senior employee. So, how do we leverage Unreal Engine to make some of these big graphics? So one of the first things I want to cover is remote control. So now I've done a lot of YouTube videos on OSC. However, there is a new kid on the block, I guess, Unreal 4.26, I think it came out in. And that is where remote control comes in. And the reason it's fantastic is because it is artist-friendly, blueprint-friendly, and developer-friendly. So if you've never used it before, you create a remote control preset, open it up, and then every value in the editor has a little, it looks like an RC car remote control next to it. You toggle that box, and then it just shows up in this web interface that it automatically generates for you. So there's, if I wanted to, for example, change the location of an object, I don't need to make any blueprints whatsoever to do that. And it shows up in this web interface, so that makes it artist friendly, because artists that don't know how to use blueprints or programming, anything like that, can now create controls on their objects, whether that be text, floats, booleans, location, rotation, all those good stuff. It is also blueprint friendly. So if you happen to need, a bit more complex, making a public variable or a function, you can still trigger that through this. So your technical artists or your, more program-centric artists can still make blueprints to do more complex things and expose them through here. And finally, it is developer-friendly. So that means that, it's a HTTP API, RESTful request, so get, put, delete, post. So in the case of a developer, that's some basic stuff you can do in Node, Python, C++, Go, all of the programming languages, and you can interact with this and make controls for it. So that's why I think remote control is a fantastic one, and we've built our own control application for Unreal on top of this. So, and that's what we used. So we use remote control, this interface as you can see here, if you can read it, this was actually what we used at Netflix Christmas. That's why we've got KC and Pittsburgh written there. However, all our events after that have used our custom interface we've written instead. However, that's all using the the remote control API. So, if you want to learn more about that, my colleague, Cooper, did a talk at Unreal Fest in the Gold Coast. It's available online to watch, and he did an entire talk just about remote control. So especially from a programmer standpoint, that is a great place to look. Now, one of the big, not issues, but problems we came across with the remote control API here is this can only control one engine, this default. Now the API itself can control multiple engines, however the generated web interface cannot. So in the case of how we do broadcasts, we have a main and a backup engine. It was important that we had two engines controlled at the same time. So we wrote a simple change to the plugin, which we've decided to put on our GitHub for you to have a look at. Now, this is not robust. It's probably full of bugs, doesn't work very well. However, for our exact purposes for this one broadcast, it worked fine. So I thought I would share it here because all of this is written in TypeScript, JavaScript, so, inspire you to maybe poke around yourself and play with it and make some changes as well. So another area in which we have a bit of problems is camera tracking. And this is where the incumbents in the broadcast space do really well. They have a program that sort of takes all the different camera tracking sources, combines them into one, standardizes it, and then redistributes it out to the render engines. Unreal has that coming with LiveLink Hub, but that's more focused for the animation and performance capture audience, not necessarily for the virtual production or broadcast AR people. So obviously, if you've ever worked on a broadcast, there's tons of different standards. We have 3D, which is from the 90s. Stipe and Moses both have their own format. NCAM has their own format. There's probably more I'm forgetting there, but there's a lot of them. So to fix this, well, not to fix this, but to organize this, we used a program called Touch Designer. So I don't know if you've heard of Touch Designer before. It's mostly in the interactive space, I want to say. But it's like blueprints, but for camera tracking and video and DMX and OSC and everything. So it gives us these nodes here. So you can see we've got a Stipe in, we've got a 3D in, we've got a Moses in, an NCAM in. We've also got a 3D out. And so I can use this to convert one of these formats to a different format if I need to. I can use this to split, which we recently did. So one of our track camera heads uses a serial port, like an actual serial port. So we use a converter to Ethernet, but I need to send that to more than one Unreal Engine. And so we use Touch Designer to receive that, split it off, and then send it off to multiple. We also have, which is really handy, is you'll notice up here the filter node. And this lets us filter the tracking data before it ever hits one of our rendering engines, whether it be Unreal or one of these other broadcast engines. So, simple filtering like Gaussian, or more complex ones like a €1 filter are very easy to do in this, and you don't have to think about how do I do it in Unreal, how do I do it in this other program. I can just do it before I even get there, which has been a lifesaver. I often think of this kind of like that drawer you have in the kitchen, which has batteries, a screwdriver, bit of tape. It's just that toolbox you can reach into when you need something. Really handy. I recommend checking it out. So another thing we came across is, these graphics are big, right? Now, I always think of it as stadium-sized graphics, stadium-sized problems. So how do we test stadium size when our office is not the size of AT&T Stadium? And there's a couple of tricky ways to do it. You could scale the graphic down, you could push it very far away so it appears smaller. The problem is Unreal has a lot of features that rely on the distance from camera or the size of it in the viewport. That means that doing that will either create problems you're trying to fix that won't be a problem, or it will hide problems that are actually problems when it is big and up close. So luckily, sort of got our heads together and we used Unreal to fix that problem. So I wrote a simple Unreal plugin, that lets us output camera tracking data instead of take it in. I did a YouTube video about it as well. Wasn't as popular as I thought it would be. I thought it was like a groundbreaking moment. That's all right. So what this lets us do is, we use a, Blackmagic card, Unreal with a digital twin of a stadium. We output the video of the digital twin. We output the camera, XYZ positional tracking, and then we have a tracked camera at a stadium scale. And this has been great for testing out, everything from just the look of the graphic to the testing the controls, as well as any kind of problems we might see, even things like placement systems. How do you place a graphic in a stadium? All that kind of stuff was solved by using this. Really handy. So here's an example of an earlier version of that Netflix graphic in our virtual digital twin of AT&T. Grab a drink of water. So there's one problem with this. And that is if I didn't give you any context about what I'm showing you here, you would probably think, what a great movie render Q render. So although I know at the time that this is, SDIs and compositing and two different Unreal engines and everything like that, the external viewer doesn't. So although it's useful for me for testing purposes, it's not necessarily useful for a client or something to prove, yes, this is a tracked camera with the video being composited, because it doesn't look like that. So just keep that in mind. We also added, I packaged this up so it's got a handy little UI here and stuff like that, which you'll actually notice when the effects happen that because it is being composited, the rocks go above these elements because it's in the background. Now, because it uses 3D, which is a standard that's been around longer than I have, it works with other graphics engines. So, the traditional graphics engines that we use in broadcast AR can also receive that tracking data and composite with the video. So here is a graphic rendered not in Unreal, however, the background is Unreal. And this has also been useful for testing purposes, which I thought was really cool. Realize I've just jumped way ahead of my slides and I've still got 45 minutes of talking to do. Maybe I'll just start again and do through the whole thing again. One of the last things I wanted to touch on was SDR versus HDR. So Thursday Night Football, right? Amazon, they did, here, I'll put it on the next slide. So they did, now I heard this in a conversation, I don't have actual data, so grain of salt and what have you, but they did testing that showed that HDR in HD has a bigger impact on audience perception of quality than 4K at SDR. So Thursday Night Football is all HDR, and being Amazon, they want to make sure they are the best at it. which brings up some interesting questions about how do we do a broadcast graphic in HDR. So most graphics, and ours included, essentially do a SDR render and then upscale to HDR using a LUT or a hardware converter. Aja makes some hardware converters. However, Unreal being a game engine and, especially from the game standpoint, it has the ability to render in native HDR. So we have the potential to do a native HDR graphic as opposed to a upscaled SDR graphic. What that means, there's plenty of open-ended questions there. Things about like artist workflows, monitoring, all that kind of stuff needs to be considered, but could be a new way to think about things or to work on things. Yes. What's next? So what is next in this space for, the streamers and the people trying to push the boundaries of broadcast AR? So here's another Thursday Night Football graphic. This one isn't Unreal. And I like to think of these as 3D full frames because they are just a full frame graphic that is floating in 3D space. And one of our recent hires, a gentleman from Austria, he told me that Unreal, it's like this kind of graphic is almost beneath Unreal because anyone can take a bit of text and some glow and make it look good. So it's like, rather than just having Unreal replace the traditional graphics engines, we also need to push the graphics themselves further, right? So Unreal has all these really cool features of, Niagara, particle effects, chaos, physics, skeletal animations, all that kind of stuff. So not only do we need to, just change render engines, we really need to push the industry almost into a higher level, I guess. So it's important to think about that when we're creating new graphics. So this is one we did for UFC and Unreal. This was just a test, but looking at liquid effects, for example, covering everything, holding animations, we've got the Ferris wheel in the background constantly moving. So, just really trying to shift your thinking around graphics. Now, the other thing Unreal can do, is to gamify graphics, right? Because it is a game engine. So the ability to take an input, whether that's from data or whether that is from the talent, and actually do something more game-like with that. So here's a great example we did, call it our sports analysis tool. This takes, inputs from the presenters and actually creates a more game-like experience for graphics, which is really cool. And then we can also start, because of that, we can start to gamify the broadcast experience. This F1 ghost car is a fantastic example of, you see this kind of stuff in video games. A ghost car showing you a prior lap time, except this is done in Formula One in a live broadcast, which is another fantastic example of sort of gamifying the experience a bit more, and the audience is better for it. So that is my 40-minute talk compressed into 20 minutes by accident.